Hello, ladies and gentlemen. My name is Mr. Bryce, and I'm with Susquehanna Valley High School here in Conklin, New York. This is Lesson 8, pages 25 to 26 for Common Core Algebra 2. This is the non-Regents version. If you don't like what I'm saying or you can't understand it, you can listen to the writer of these worksheets for math, e-math instruction. There he is right there. Just scan the QR code. Okay, let's get ready and go. Exponential functions are very important to mathematics, and their inverses are very important to mathematics also. Just as important as addition and subtraction are inverses, multiplication and division are inverses. So exponential functions, their inverse is known as logs. The function f of x equals 2 to the x is an exponential function because x is in the exponent. The variable is in the exponent. It's shown on the graph to the right. There it is. Now, you don't have to copy this down. Here is the exponential graph. What's the other thing doing there? The other thing is the line y equals x. And when we reflect something across the line y equals x, that is known as its inverse. Okay, let's get back ready to take notes again. So what we did here is we did a table and plotted it. Is this function 1 to 1? Is it 1 to 1? Yes, because for every x there's only one y, and for every y there's only one x. For every x there is only one y, and for every y there is only one x. In other words, it passes the horizontal and vertical line test. Passes the horizontal and vertical line test. Based on your answer from part A, what must be true about the inverse of this function? Let me see. For every y, there's one x, and for every x, there's only one y. That means that its inverse is also a function. Not only a function, but is also 1 to 1. Create a table of values below for the inverse f of x equals 2 to the x and plot this graph below. You remember the definition of inverse? Just change the x's and y's. Well, we're given points. So that means that the old input is the new output. So this is the input. This is the output. So just change the x's and y's. So on top is going to be 1/8, and then we have 1/4, and then we have 1/2, and then we have 1, 2, 4, and 8. For the y values, -3, -2, 1, 0. See, I'm just taking these, bring them to the output line, 1, 2, and 3. Then it asks for us to plot them. So if you plot 1/8, -3, it's going to be right about there. 1/8 in the positive direction of x. 1/4 in the positive direction of x, -2 in the y value. Then 1/2, and it's going to be -1. There we go. Just had to correct that on the table. And then at 1 for x, it's 0 for y. Keep on going. 2 for x, 1 for y, 4 for x, 2 for y, 8, and 3 for y. Connect them smoothly. Even though it says plot, I want you to graph them. Put an arrow. Okay, we talked a little bit before about the domain and the range. So let's put right down here underneath the box the domain for a log function in standard form. Domain is all the x's such that x no equal to 0 to infinity. Okay. It's never, it has a vertical asymptote there, has a vertical asymptote right there at x equaling 0. The range, all y values such that from negative infinity is less than x is less than positive infinity. You're like, hey, it doesn't look like it's going out to positive infinity. Well, it does very slowly, like a sloth. What would be the first step to find an equation for this inverse algebraically? Wait, what did I just say? Oh yeah, write the step down. Write the step down. It is change the x and y, then solve for y. I don't like this definition of a logarithmic function because it gets people a little bit confused. What I like to say is to find the inverse, we're going to follow this right here. The base is the base. The answer is the exponent. What do you mean by that? We're going to take a look at that a lot closer on the next page. But b was the base. B is now the base for the exponent. The answer is the exponent. And then this is the only thing that we're left with. So that has to become the new answer. Based on this, we see logarithmic gives us output y value. The exponent we must raise to b in order to produce this input. So here we go. Evaluate the following logarithms. If needed, write an equivalent exponential equation. Do as many as possible without the use of your calculator. Are you ever going to be without your calculator? Do as many as possible. Don't do as many as possible. Do all of them. So the base is the base. The answer is the exponent. X. Okay. Hello, Mr. Bryce. I just said the base is the base. The answer is the exponent, and then that's the new answer. Okay, 2 raised to what power equals 8? 2, 4, 8. X equals 3. Get it? 2, 4, 8. 2, 4, 8. 2 times 2 is 4 times 2 is 8. Okay, the base is the base. The answer is the exponent, and whatever we're left with, that's 16 is our new answer. So 4 to the what power? Let me see. 4 times 4 is 16. 4 times 4 is 16, so that's just 2. There we go. The base is the base. The answer is the exponent. Equals 625. We talked about this one a lot in the first 4 sections of this. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. Try that again. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So x equals 4. Cool. Okay, the base is the base. The answer is the exponent. We have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So x has to, what am I doing? X has to equal 5. 10 times 10 times 10 times 10 times 10 is 100,000. Okay, the base is the base. 6 to the x equals 1 over 36. Oh, why don't I get rid of this fraction by saying that it's 36 to the negative 1? So now I know that whatever the x is, it has to be a negative number. Let me see. 6 squared is 36, so x must be negative 2. Hang on a second. Let's see what happened here. So if you didn't hear me, x has to be -2. Had a little bit of a computer glitch there. Again, we're going to make this a negative exponent. So the base is the base, the answer is the exponent, and it has to be 1/16. Since this is a fraction, we know that this is going to be 2 to the x equals 16 to the -1. So let me see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So x equals -4, because we know that it has to be a negative exponent. The base is the base, 5. The answer is the exponent, and it has to equal the square root of 5. Well, do we know for a fact that square root means write it to the 1/2 power? Do we know for a fact that square root means write it to the 1/2 power? Time for a question. So now x equals 1/2. The base is the base, 3 is the base, the answer is the new exponent, equals, so this is the 5th root of 9, or 9 to the 1/5 power. So I know that 9 is really 3 squared. So 3 to the x equals 3 squared to the 1/5. Multiply these two together, and I get 2/5. So x has to equal 2/5, because I just used the rule of common bases right there. Pretty neat. It's critically important to understand that logarithms give exponents as their outputs. Okay, so that's what we're doing. That was the output. We'll be working on multiple lessons on logarithms, and basic understandings of the inputs and outputs is critical. So here we go. If the function here, +9, was graphed on the coordinate plane, which of the following would represent its y-intercept? Okay, this is really neat. So here we're talking about a shift. We're talking about, there we go. We're talking about a shift that's going to be going up 9. So we're going to be moving the graph up 9. Okay, and then this is going to be moving it to the left 8. Why is it going to the left? Because that says plus. If that said minus, we would be going to the right. So we're going to the left 8. We're going up 9. So what we have to understand is that the base is 2. So 2 to the x equals 8. And we know that x equals 3. So when we're graphing this, we're going to have a vertical asymptote. Right now I'm graphing log base 2 of x. So we have a vertical asymptote, and it goes through the point 1, 0. And then it's also going to go through the point 2, 1. It's going to go up fairly fast. Now what's going to happen is that, like I said, it's going to go to the left 8. It's going to go up 9. So the original function had no y-intercept, but because we're moving it to the left and we're moving it up, it is going to have a y-intercept. Now normally, the y-intercept would be 3, because it's for this part is solved. But because we moved it up 9, we've got to move that up 9 and have the answer to be 12. Now let me just double check. And I just checked the work, and that is correct. Between which two consecutive integers must the log of base 30 lie? Okay, now this is a great question. The base is the base, and the answer is the exponent. So 3 to the x has to equal 40. 3, 9, 27, then 81. Let me see. This is 3 to the first, 3 squared, 3 cubed, 3 to the fourth. So which one does this lie? It lies between 3 and 4. You understand how I did that? I just did, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Found out that these two are what 40's in between. 40's in between 27 and 81. Got it as between 3 and 4 because it's the third and fourth number. Most calculators only have 2 logs, and they can evaluate directly one of them. Okay, log base 10. It's so common that's the common log, and it's written without the base. So this is the same as that. So whenever you see log without anything written as its base, we know it is log base 10, or the common log. Log. The other one is the natural. Natural log is written as ln, and that is log base e. E is a number, and that number, e, is 2.7. Then Andrew Jackson became president in 1828, so I said his name twice, and it's 1828. Isosceles right triangle, 45, 90, 45. So there is E, 2.7, 1828, 1828, 45, 90, 45. 2.7, Andrew Jackson, isosceles right triangle. Okay, so that's natural log, and that is what E is. Evaluate each of the following using your calculator. Let me see. The base is the base. The answer is the exponent, and it has to equal 100. Let me see. 10 to what power is 100? 10 squared is 100. Okay, now here, the base is the base, and the answer is the exponent. So let me see. This is 1,000, which is the same as 10 to the negative 1, 2, 3, negative 3. So let me see. They're right there. They're lined up. Common base. So x is negative 3. And here, the base is the base. The answer is the exponent, because that equals x. And then, let me see, that's really 10 to the 1/2. So x is 1/2. That's no problem. Slam dunkaroono. You can now do the next page and next 2 pages. That's 1 page. That's 2 pages without any problem. That's for homework. This is Mr. Bryce signing off. See you in class if you have any questions. Bye-bye.